long hours, late nights, and the expectation of total dedication. The cultural assumption is that pursuing a successful career requires a woman to sacrifice her devotion to having and raising children, a concept sociologists call the competing devotions myth. Employers and long-standing cultural schemas frequently operate on the premise that mother and worker are incompatible identities. You can supposedly excel at one, but only at the expense of the other. In 2008, sociologists McQuillan, Greil, Schreffler, and Titchener put this cultural assumption to a direct empirical test. To measure this, they constructed a dependent variable called the Importance of Motherhood scale. It is a continuous metric built by averaging responses from a highly reliable array of survey questions. We are going to deconstruct Table 2 of their published findings. We will see exactly how linear regression bridges the gap between raw survey data and social theory. Human behavior results from overlapping social forces, race, education, work, and age, pulling on a central outcome. OLS linear regression translates these into independent mathematical relationships. By reverse engineering Table 2, we observe how regression isolates variables to challenge the motherhood mandate. A regression table is a rigorous mechanism for testing competing sociological theories against reality. This table summarizes the study's regression model. We will focus entirely on the foundation, the data column for mothers, and the row at the very bottom labeled constant. Every linear regression model is built on a specific mathematical equation, y equals a plus bx. Mapping that formula to our table, the constant value of 3.646 represents the y-intercept, or the letter a in the equation. By methodological rule, the constant provides the predicted value of the dependent variable when all the independent variables, the x values, are strictly equal to 0. The researchers measured the importance of motherhood on a scale of 1 to 4. A baseline constant of 3.646 sits near the absolute top of that range. Conceptually, this means that even before factoring in specific life circumstances like income or relationship status, the baseline valuing of motherhood for mothers in this sample is deeply entrenched. The constant establishes our statistical anchor. It is the baseline from which all other identities and choices will push or pull the final prediction. Looking at the section of this table labeled Rational Choice, we can specifically target the continuous variables for education and the importance of work. The coefficients here represent continuous slopes, or the letter b in our formula. They tell us the predicted change in our dependent variable y for each exact 1 unit increase in x. Rational choice theory predicts that highly educated women face higher opportunity costs in the workforce. Theoretically, this economic penalty should lower the value they place on motherhood. We look at the b coefficient for education in years. The value is 0.005, and notably, it completely lacks statistical significance stars. The data flatly rejects the rational choice theory expectation. Within this sample, there is no statistically significant relationship between years of education and valuing motherhood. Now we drop down to work important. Here, the b coefficient is a positive 0.052, accompanied by 2 asterisks denoting a highly significant p-value. This scatter plot visualizes the dynamic. As the self-reported importance of work success increases on the x-axis, the importance of motherhood on the y-axis rises right alongside it. Valuing work success correlates positively with valuing motherhood. The data statistically dismantles the competing devotions myth. Continuous variables are straightforward, but nominal identities like race or relationship status present a methodological problem. How do you calculate a slope for categories that have no numerical order? The regression equation requires a true 0 to function. Because nominal data is arbitrary, you cannot have 0 race. It inherently lacks this requirement. Looking at this frequency output from PSPP, we can see how researchers manually construct a statistical workaround. They trick the equation by creating dummy variables. This involves taking specific nominal identities and coding them as a binary 1 or 0 switch. The logic is rigid. The 1 represents the specific target group being tested, and the 0 represents absolutely everyone else. Putting these binaries into a model comes with a critical caveat. To prevent the math from breaking down entirely, one category must be intentionally excluded from the regression run. This excluded category becomes the necessary true zero. It creates the statistical reference group against which all other identities will be measured. Returning to the regression table, we can spot these dummy variables in action within the culture and identity rows for Hispanic, Black, and other race. Scanning that list, there is a conspicuous missing category: white non-Hispanic respondents. By leaving them out of the list, the researchers funneled the white respondents into the zero category, establishing them as the reference group. This dictates a unique interpretation rule for dummy variables. The calculated slope is not a one-unit increase. It is the calculated difference between the specific test group and the hidden reference group. We locate the specific B coefficient for Black mothers, which reads as -0.161. Translated into plain sociological terms, holding all mother variables like education and work constant, Black mothers score 0.161 lower on the motherhood importance scale than the white reference group. The authors connect this statistical finding directly to the literature. They theorize this difference exists because white women may be more susceptible to the normative pressures of the cult of domesticity. By funneling a reference group into the constant, the regression model successfully isolates the specific, quantifiable effect of racial identity on cultural expectations. Expanding our view of the table to compare both data columns simultaneously, we can identify what actually does compete with motherhood. Let's look closely at the leisure important row. For non-mothers, valuing leisure carries a highly significant negative slope of 0.204. This contrast is vital to the paper's thesis. For non-mothers, motherhood directly competes with free time. For mothers, however, work and motherhood operate as mutually reinforcing values. Scrolling to the bottom of the table, we evaluate the overall success of the equation by checking the adjusted R-square values. R-squared serves as the goodness of fit. This measure dictates exactly how much confidence we can have in our model's ability to actually explain the dependent variable. The disparity is stark. The exact same variables explain nearly 32% of the variance in attitude for non-mothers, but only 10% of the variance for mothers. That leaves a massive gap of unseen sociological variables still at play in the background. What missing variables account for the other 90%? What did the researchers leave out of the equation? Statistical methods provide the objective what and how much. In the upcoming seminar, it is your job to debate the theoretical why.